I'm Sarah from Firebolt, and I'm joined here by Yaron from Bigabid and Elad, my colleague and a solution engineer from Firebolt. When it comes to analytics, especially when we're talking about large-scale data or high concurrency usage, query latency is a big issue that comes up. So Bigabid has an interesting use case that Yohan will be sharing with us today. We will take a look at how they built their data stack, what they learned in the process, and what their analytics pipeline looks like today. So Yohan, it is great having you here today. Thanks for joining us and sharing with us. And let's kick things off with a bit about what Bigabid does for those of us who are not familiar, and what it is that you do and your team does at Bigabid.
Great. So good to be here. Good evening, everyone. Good morning. So Bigabid is an AdTech company. We use machine learning in order to serve our clients and make them profitable. And since we're in the AdTech industry, many of you probably know that AdTech means large scale of data. So Bigabid is an entire data company. Many of our employees are either engineers or data scientists, and that's what we do. We use data in order to help our clients, and we use data. In my team, in the BI team, we use data in order to serve our management, in order to serve our campaign managers and customer success, and you name it. The BI team. I'm the BI team leader, and the BI team supports all of Bigabit's data, the analytics, and we're doing it by using many data infrastructures. We use streaming, we use ETLs, and at the end of the funnel, we have to show the data and tell a story. So this is what we do.
Perfect. So, what was your data stack originally? Tell us about how you guys got started, how you built it that way, why you built it that way, what was some of the reasoning before, just like tell us about where you guys basically got started. And I will also show here while you're talking about it, I will show a little diagram.
So I started working at Bigabid almost 2 years ago, and we had like a messy pipelines. We had some data in MySQL, some data in Redshift. We used Airflow to orchestrate some of our ETLs, and Absolver to use other data sources, some streaming, and then we used to show it in Tableau. So what that means is that we had to approach many tables. So every dashboard or almost everything we wanted to show to our company was built on one table. So sorry, not on one table, on many tables. So let's say we wanted to show an analytics for something, we built an ETL, a specific ETL that at the end of the funnel went to a table, and that was the dashboard itself. So if we have like 100 dashboards, we had 100 tables, and it was really messy, and it was a bit tough to show everything we wanted due to this data stack. So we used Redshift as our data warehouse, and some of our old ETLs went to MySQL, and we started wanting to show real-time data. So we used Absolver to streamline our small part of our funnel, and then we showed it in Tableau.
And how did that work for you?
So as I said, it was a bit messy, and we had to control many tables. It wasn't in one place. We had to learn several technologies. We used to load code by Node.js, and some other code we used Python, and it was like I said, messy, and it was hard to maintain. Our recovery time was really, really, really slow. And we wanted to show, like I said, we wanted to show real-time data. We wanted to show more parts of our funnel. We wanted to show, we wanted to help the business as much as possible.
So, I mean, what
Uh,
was like in terms of the practical cost to the business? So what was really the implication of not being able to show and run the kinds of analytics that you wanted?
so we had some trade-offs that we took under consideration. We knew we couldn't analyze the all data. We knew we had to aggregate in higher granularity data. So if we wanted to analyze 2 or 3 years of data, we had to like see it by 1 or 2 dimensions, or maybe three. Otherwise, either Tableau got stuck, or we had to show less years, less data, like I said. In addition to that, we couldn't really analyze real-time data since I don't know how many of you guys worked with Tableau in the past, but if we want to show data with Tableau has two methods, extract or live, and if we're doing a real-time dashboard, we have to work in a live method in Tableau, and that means either optimize Redshift, and that was pretty hard, showing data, that big data in real time.
Okay, got it. Perfect. And well, not perfect. It was far from perfect. I guess
Yeah.
I'm curious, in your journey, like at what point did you realize that this is moving from, because I talked to a lot of people who, experience this, like either maybe their data is growing, or they're using concurrency, the query concurrency is increasing, and then they reach a certain point where they find that they do need to kind of rethink their pipeline. So, I mean, you started with the solution. Was it kind of okay at first? And then, like, did you have an aha moment where you realized that it's really impacting the business?
So I think we had like a few things under consideration. The first one is that we wanted one source of truth. You don't see it here in this diagram, but Bigabid also has a system analytics where our campaign managers analyze in real time their data and optimize their campaigns. And there's the BI system, and we wanted to create one place to rule them all. But actually, we wanted our campaign managers and the management and our customer success and everyone that uses data in Bigabid to see the same thing. We dealt with many discrepancies previously, and that was like a real main part of our rethinking. In addition to that, like I said, we really wanted to start seeing real-time data also in our BI reports. And we wanted to start analyzing more angles in our funnel, because at first step, we could analyze like, let's say 50% of our funnel and understand what's going on there. And in the current situation, we couldn't analyze more stuff. Like let's say the bigger chunks of our data that starts with auction in AdTech, that goes like 1 billion auctions in a second. We couldn't do it. Even if we aggregated the data, let's say in 2 or 3 dimensions, it still goes up to like really large tables that can't be extracted in Tableau, or you have to just query it every second and wait 15 seconds or a minute or two just to get a response.
Yeah, understood. So what did you do at this point? I mean, I understand that you kind of decided you want to evaluate some different options. Did you consider, trying to basically scale the existing platforms that you have, like Redshift? What were the solutions that you decided to take a look at and consider?
So that was around the time that I came to Bigabid, and our legendary architect, Eyal Trabelsi, started analyze what's needed, what Bigabid really needs. I started getting offers from several databases and there were warehouse companies, and then I came and we started like creating a project and understand what we want to analyze, what do we want to test, with which things are most important. And as I said at the beginning, the one source of truth was really in our top of our mind. And Eyal got few suggestions. He started with Snowflake, and as a startup, we like said, let's wait. And then we started analyzing data in Redshift and started to scale it up. And then Eyal found out about Firebolt, and we started like doing some tests in Firebolt and also with MySQL. So the real tests were between MySQL, Redshift, and partially Snowflake and Firebolt. So what we did is basically we took a big chunk of data that we used in Redshift, and let's say we took 2 or 3 months of that data and loaded to Redshift, to a big engine in Redshift, to a big cluster, sorry, and also took the same data, the exact same data, and loaded it into Firebolt. And we started running the same queries and compare between them. And at the beginning, before we knew about aggregating index in Firebolt, later on, Elad will share this data. We started seeing like we're running in Firebolt, it takes 10 seconds. We're running in a big cluster in Redshift, it takes a minute, it takes 2 minutes. Many queries, and that was like our benchmark. We tried to do the same thing in MySQL. We saw that's out of the question. It doesn't work, and then we decided to.
Sorry to interrupt, but you also mentioned Snowflake, that you also tested them.
Yeah, we analyzed it at first, but we didn't like came to a real test. We just did it between Redshift and Firebolt.
Okay. Okay. So yeah, what happened next?
What happened next? So, like I said, so I keep on repeating the one source of truth thing, but like I said, that was the real deal for us. And we started by migrating all of our old data, all of our legacy data and dashboards and whatever. We started migrating it to Firebolt. That was the BI part. And in parallel, we started working on our one source of truth project, and we started creating, as you see here, we streamlined data directly from AppSolver instead of going through Athena or orchestrating it by Airflow and do a lot of manipulations. We started streaming it from AppSolver, and then we started creating, after we finished the migration of the legacy data, we started by creating one big table, one huge table actually, that gathers a real big part of our funnel, and then we started loading it to Firebolt. We started creating dashboard on top of that huge table in Firebolt, showed it in Tableau. And in addition to that, we started the migration process of our analytics UI, or of our system analytics for Bigabid. We started migrating all of the processes that went through MySQL in the past, which recovery time. We took a big part of our development team responsibility and loaded it into Firebolt instead of using MySQL. And MySQL at that point had like hundreds of tables that supported like 10 views in the UI. So we took that, and in one table in Firebolt, one process, one huge process, no, not something small, but in one process, we were able to create this one source of truth. We saved raw data and aggregated in real time We loaded data, as you can see here, from Absolver every few minutes to Firebolt, and the analytics went in Firebolt in real time. So that was a real big deal. In addition to that, we could develop additional dashboards which showed other parts of our funnel, like I said, other angles. Starting from auctions, we could analyze the entire funnel of Bigabid, from auction to bid to an impression and install, etc. So that was a really big deal. We started showing data, like, let's say, compare year over 2 years, and see the real growth of Bigabit. So yeah, it was like a long trail, but we really see how is it going. It really evolved very, very good.
So when it comes to the kind of data that you work with, what is really the difference between, analyzing a few months back versus, like you said, expanding that search window to a few years? Like, what is the actual difference in the analytics?
Can you repeat? Sorry, what's the difference
Yeah,
between what?
what is really the difference in the results that you see in the results of the insights of analyzing, let's say, a few years versus the weeks or months that you were analyzing before?
So basically, now our campaign managers can understand way more things than before. They don't have to do the same mistakes they did in the past, because now they can see what happened for their campaigns in case they did something that they shouldn't do. But furthermore, they could understand better trend lines. They could see seasonality. They could see way more things than before, and I think that really created it helped the business grow. I mean, our analysts could now go to one table and don't do complicated processes, and they just query the one huge table that we did, or even better, they go to a dashboard that works in real time and analyze what happened in the last 2 years for a specific campaign. And I think that really help us grow faster, understand better how our data behaves. That was really contributed Bigabit.
How did query performance how was it impacted, like, overall, um, after you implemented Firebolt versus your previous, Redshift and Athena-based pipeline?
So I think now people like to query more via the UI, via Firebolt UI. Uh, Results are way faster. Let's compare a specific query to Athena, for example. If we run one of our pipelines that we used to run in Athena, we used to split it into few chunks and then aggregate everything. Now we just aggregate in one big table in one chunk, and it processes in milliseconds. I think he will show it. He will see it in a few seconds. But yeah, it was really, really easy moving to Firebolt, both by querying and also by getting results way faster than we used to do.
So I know that you guys are growing really fast. So what are your future plans in terms of your data and with Firebolt? What's ahead?
So what's ahead? I think we have a few more processes that are in our pipelines, taking more data from our APIs. And I think the really big vision in the future is by creating a UI to our customers and not just inside of Bigabid, to be supported under Firebolt. So that's something that we are aiming at. And of course, we are supporting more customers now. Like, Bigabid is growing, as you said, and our customers are growing. And it means more analysis, more dashboards, more users, which means more concurrency on our database and support way more data than before.
How have you found concurrency to be handled so far by Firebolt?
So in my perspective, let's say we have 60 users in real time that querying all the time Firebolt. We have multiple dashboards that runs multiple queries
Oh,
underneath
sorry,
that
Yolan,
dashboard.
I don't know if it was me. I don't know if it was me, but I think that you just got cut off there for a second. If you just want to repeat that, you just started saying about concurrency.
Sure, sure. So in my perspective, I see the growth in our users. I see the growth in queries under Firebolt, and we have multiple queries running multiple multiple queries in the same time, 60 users or more, and some of our dashboards create more than 10 queries at the same time at the same running time, meaning we can get like to 100 queries at in the same second, and everything works, and uh, we don't have to worry that much about splitting our nodes or splitting our stress, and it's really good.
Okay, well, thank you so much, Yolan, for sharing all about your use cases. And yeah, I think that at this point, I'd like to hand it over to Elad, the solution engineer at Firebolt, who's been working closely with Bigabid, knows the use case inside out. And maybe with Elad, you can share with us how this actually works under the hood, because Yolan is making these statements which are pretty extreme statements, right? This kind of concurrency, this kind of millisecond performance. And I'm just wondering if you could share with our viewers how this actually works under the hood.
Yes, of course. Hi, everyone. Do you see my presentation, by the way? Do you see it well?
Yeah, we can see.
Okay, so thanks, Yaron, very much. It was very interesting. Um, Today, I'm excited to speak a little bit about Firebolt and how, and actually, I would like to start by introducing Firebolt. So, Firebolt is a unified platform combining the capabilities of data warehouse with the speed of query accelerator. As well, Firebolt specialized in doing complex processing for BI reporting and exploration. Um, and Firebolt is built to serve low latency and high concurrency data applications, all this in a very high performance. So now, after we understood what Firebolt fits for, let's get deeper and speak about some powerful features of Firebolt that can significantly enhance the way you handle and analyze big data. So specifically, I will be focusing on two types of indexes. I will speak about primary indexes and aggregating indexes and how they contribute to make Firebolt an excellent choice for that data analytics. And I will also speak and touch a little bit about the magic behind the Firebolt Query Planner. So let's start with the primary indexes. Let's imagine that you have a massive library of books, but they're all scattered around. And in this case, when you want to choose a specific book, it could be kind of nightmare. I guess you will agree with me. And so this is where indexing comes in. In the world of databases, a primary index works like a strictly organized catalog. It helps Firebolt quickly locate and access the data that you need to find, that you want to fetch. The beauty of primary indexes in Firebolt is that they're designed to optimize your data retrieval. It means that when you ask a question, or in technical terms of our data world, when you run a query, Firebolt knows exactly where to go and find the answer. The answer, I mean the results. So it's like having a librarian who knows precisely where every book placed, and this efficiency, this is where, sorry, I just forgot to say. So this efficiency drastically reduces the time that it takes to get your results, and making your data analysis faster and much responsive. So this was a little bit about primary indexes and this powerful feature. Now let's speak a bit about aggregating indexes. So if we will continue with our library analogy, let's say suppose that you wanted to know how many science fiction books published in the 80s. So with the traditional setup, what you would have to do, you had to count each one manually, which was very time consuming. So what aggregating so in aggregating indexes, what it's doing is pre-calculates and stores summary of the data, like counts, average, sums, medians. So every aggregations and making it super quick to get such insights. So in Firebolt, aggregating indexes take this concept to the next level by allowing you to perform very complex aggregations and calculations to your data with incredible speed. It means that it means that you can run a very detailed analytics and get insights in real time, which is very game changer for businesses like Bigabid that rely on up to minute data to make their decisions. Later, I will show you how it reflects in the queries. So this is how aggregating indexes works. And now I will speak a bit about our planner. So behind the scenes, making all what I spoke about before being possible is our query planner. So let's think of it like the brain behind the operation. Okay, it's a query optimizer. Okay, it might sound a bit complicated, but it's essentially a smart system that figures out the best way to execute your queries. It looks in the indexes that you have, the way your data is joined together, and how it's distributed across the system, and then it comes up with the most efficient plan to get the results and the answers that you need for your queries. So this ensures that every query that you run is done in the most performant way and saves you a lot of time and resources. So the combination of these three features, I don't call it feature because optimizer is not a feature, but the combination of these three things, it makes Firebolt an incredibly powerful tool for anyone who is working with big data. So after I explained you a little bit about how Firebolt works and about these two indexes and our optimizer, now we will go deeper a bit and speak about Bigabid. So Bigabid have dashboards that help campaign managers to generate a report of auctions. So here we can see, by the way, do you see my the whole
We can.
file? Do you see everything? Okay. So here you can see a query from a light dashboard that runs in milliseconds on a table of more than 8 billion rows. Yaron, correct me if I'm wrong, but it's around 8 billion rows. It's one query from 31 tiles that all the queries here is running at the same time. All of them is scanning 8 billion rows. So in order to scan such a huge amount of data, to perform heavy calculations and aggregations, and to group by such a large number of fields, you need to a very strong and powerful calculation and indexing capabilities. Okay, so that's one of the reasons that Bigabid chose Firebolt and a powerful feature called aggregating index, and that it fits the use case. So now let's take a look. This is the query that I just mentioned, one of the 31 types. As we can see here, there is a few columns that we are grouping by and another aggregations. It doesn't look so scary and heavy, but it's pretty heavy query that in the next slide, now I will show you when we are scanning the original table, it's running in about 33 seconds and scans over 170 gigabytes. And by using the aggregating index, which I just spoke about, it scans much less. You see, it scans 194 megabytes, and it returns in sub-seconds, in 0.16 seconds. And I just want to remind you that we're talking about another 30 queries that's running in parallel on the engine. So now let's take a look a little bit how the aggregating index looks like. It's pretty simple. Here we are adding, this is very simple syntax, I mean. So here we are just adding all the group by columns first, and then we are adding the relevant aggregations that involved in the query. And that's all. We're making it once, and every time we ingest new data, that in Bigabid's use case, it's every 10 minutes, something like that. The new data is being updated also in the aggregating index, and then it makes the queries run fast and get real-time data. I think that's all from my side, Sarah.
That was really interesting, and I already knew all about this, so so thank you for sharing. And yeah, with that, I think we've gotten to the highlight portion of our session. Yaron, I'd like to give it back to you to show us a demo.
All right, cool. So I'll try my best here. Everyone sees my screen, yeah. So what you see here, guys, is basically a dashboard that we couldn't show in the past. What goes around here is actually see our top of our funnel, see what goes on in our auction. As I said in the beginning, Bigabid analyzes 1 million auctions in a second, and by analyzing it every second and understanding what's going on our top of our funnel, that can save us a lot of money. Our operations team uses this dashboard to understand exactly how we perform, where we can save money, where we need to perform better, and stuff like that. So if you remember the ugly query that Elad just showed you, by ugly I mean like very wrong aliases no one uses. That's what happened when you put live data source in Tableau. Tableau creates really scary, let's say, queries and gives really bad aliases. And we could leverage Firebolt here to create a live dashboard that works in real time. Of course, it works head hoc. We show data for until yesterday. We don't show it in real time. That's not something that needs to be done. But the table, the underlying table for this dashboard contains, like Elad said, 8 billion records. And it's not just that it has 8 billion records. We multiplied it in this dashboard by 4 because we called the same table 4 times to create this dashboard to work fast and create 30 queries concurrently. So we can analyze here our exchanges performance, and we can see a trend line of how our exchange work. Of course, you don't see the exchange name. We can see our placements, meaning where we are putting the impressions, where the auction says we can put impression in. And we have multiple dimensions here. This table is really big since we split by many dimensions. And if you just take a look in a second, I'll change the date and you'll see in a second, everything changes. And I can do it many times and still works. And our users are not getting frustrated by exploring what's going on. We can also see here, for example, I'm changing dimension. It works in a second. We can see many things here. We can also expand the dimension and understand what's going on in multiple dimensions. Let's say like that. Even analyze the country. Let's say I want to understand what's going on in a specific country. And you can see everything changes here, and it works in a second for 8 billion records times 4. That's something we couldn't achieve in the past. For now, it really works. And I think our clients are really happy with that. And I have no anything else to add on that.
Super cool, Yolan. Thank you so much for sharing. We do have a few minutes for some Q&As, and there are some questions that came in, so I would like to leave a few minutes for those. Before we do, I would just like to share really quickly. Yeah, so I would just like to mention that if you would like to take Firebolt for a spin, give it a try on your own data set, see how it can accelerate your analytics, your queries, then I would like to invite you to try Firebolt for free with some free credits that we'll throw in. You have the link right there on the screen. Firebolt.io, try Firebolt. You can go in now and we'll get you set up with your free trial account. And now I'll go ahead and move into the Q&A. So the first question that came in, this is actually from somebody anonymous. An anonymous attendee who is skeptical about indexing from what I'm reading. So this could actually be an interesting question, Yolan, maybe for you to take, since I know that you do utilize so much indexing. So the viewer is saying, can you review what pieces, if any, of the indexing, I guess, you get out of the box, or is it applied automatically? In my experience, you need to properly define and implement indexes, which are not free, and I haven't seen the results from these automatic indexing. What do you say about that, Yolan?
So I think first, like in every index analysis, you have to understand how your users will approach the data set that you created. But in terms of difficulties or magic, once you implement it, it just works, seriously. Of course, you have to understand what do you want to achieve. But let's say you can create not a huge index, but let's say a medium index, and it will create it will really leverage your performance. You'll see queries are running in milliseconds, and your analysis didn't take like more than a few hours, let's say.
I just want to add that we can separate it to two kind of indexes. So for the primary indexes, it really depends on your query patterns and the cardinality of your columns. But as you said, once you choose it correctly, it just works perfectly. In aggregating indexes, you can create as many indexes as you want. And our planner will know to choose the most optimal aggregating index. So for every different query with a different cardinality or pattern, you can create a different aggregating index. And I didn't speak about our join accelerator that we called it in the past a join index that is automatically created when you're doing when you join involved in the queries. And this one creating a hash map object behind the scenes and accelerates them dramatically the queries that involve joins. So this is another part of the joins that I didn't speak about.
I can add on the joy thing. So we're using Firebolt for a year now, and at the beginning you had to declare the join index. And what Elad is saying now, that's real magic. It works out of the box. You don't have to declare the join index. It really works.
Awesome. The next question we have is from Vinay. He asks, can we use Firebolt for a large OLTP batch process? So you're actually asking if you can use it for, so OLTP, like transactional. Elad, could you share any insight as to this one?
Can you repeat the question?
Yeah, can we use Firebolt for a large OLTP batch process? So from what I know, Firebolt is an analytical platform. So it's not a transactional platform. So the answer would be it's pretty much for, yes, it can be used for batch processing. It's an analytical platform for analytic workloads. That's the primary use. And we have two more questions. So the first one is, does Firebolt utilize caching in order to accelerate query response time?
So yes, this one is pretty simple. So yeah, Firebolt using caching like many other cloud data warehouses and databases. We're using a caching mechanism. So every query that the customer is running is caching the data or part of the data. So the next querying of the same data or data range is being fetched and retrieved much faster. I don't have so much to add about it, just that we're using it.
All right, we have actually another one came in, so now we have two more, and we're going to finish with those last two. If we'll just go through those quickly. So the next one is, how does scaling data volumes affect query performance? And I think, Yohan, that you did touch on this a little bit, but if you just want to expand a bit on how does scaling, I guess, data size and concurrency for that matter affect the query performance?
So I would say, like, let's say we started by analyzing 1 year and then adding another year and another year. And in my perspective, we got the same results, being using 1 year, 2 years, or 3 years. It didn't change. In addition to that, like I said, we had multiple users joining to Bigabid and multiple dashboards that didn't work before or didn't work in live before. And now they are working in live method, and our analytics UI scenario, which creates more users. So both concurrency and scaling up, as long as you define your data model as should, you define your indexes, we didn't see anything that affects that.
Okay, perfect. And the very last question, which we'll finish up today with, is how did the total cost of using Redshift compare to the costs of your Firebolt pipeline?
So in our case, I think we need to take under consideration we had MySQL and Redshift. Okay. In cases that we didn't control and cases we did control. And in total, if we'll take our scenario with Athena and Redshift and MySQL, we could save a lot of money there. Let's say for Athena, everyone knows that you run a query, you pay for scan. And when we run, let's say half a terabyte a day, half petabyte a day of queries, you don't have to pay for that yet. you can run and analyze as much as you want, and many dimension as much as you. So we could do way more in less money.
I just want to add to what Yaron said, that as Firebolt charts based on engine type runtime, so you can control your costs and isolate your workloads. It means that you can choose cheaper engine for small workloads and bigger engine for heavier workloads. You can also use the same engine and autoscale for the most cost-effective engine based on rush hours or calm hours. So it's really controllable, and that's all. That's what I wanted to say.
Yaron, Elad, thank you very much for joining us this morning. Really interesting to hear about your use case and deep dive into the technology behind it. And I'm going to wish everybody a good rest of your day. And once again, feel free to hop on the website and grab your free trial account for Firebolt. Thank you, everybody.
Thank you very much.
Thank you.
Bye-bye.
Bye.